For my first presentation, I had to prove proposition 6.1. So there are two ways to prove this. We're going to first prove the right way. So the first thing that we're going to do is we're going to say let v, w, and y be vector spaces over F. And we're going to assume that alpha is a linear transformation. So now that we have that alpha is a linear transformation, we can say that if v and v prime are in the vector space V, and C is an element of F, then if we consider V times W, we have V alpha V plus V prime alpha V prime would equal, if we combine them, V plus V prime alpha V plus alpha V prime, which then we can rewrite this as V plus V prime and alpha parentheses V plus V prime. And this is an element of the graph of alpha. So that shows addition, and now we have to go to scalar multiplication. So now we're going to consider C times V alpha V, which can then be rewritten as CV C alpha V, which we can bring that C now into the parentheses with the V. So we have CV alpha CV, which is also a graph of alpha. So we showed both under addition and scalar multiplication. So then we can say that the graph of alpha, is a subspace of V times W. So that is the right way. Now we're going to prove the left way. So now we're going to assume that V times W is a subspace. So for V prime, an element of the subspace V, and C is an element of F, we now have basically what we have written on top. V alpha V plus V prime alpha V prime can now be combined. So we have V plus V prime over alpha V, not over, I'm sorry. My mind is in high school math. So now that we have that, we can say that this is an element of the graph of alpha, so that alpha V plus alpha V prime equals alpha parentheses v plus v prime. So we have the addition shown. Now we have to show the scalar multiplication. So similarly, c times v alpha v, you can bring that c into which then is a part of the graph of alpha. So then we can say c alpha v is equal to alpha c v. So now that we've proven scalar multiplication, thus alpha is a linear transformation, which is A is an element of